Howdy class. This video is on string operations in Python. We're going to look at some of the more advanced features of strings. We dabbled with them briefly earlier in the course, and we learned a few methods here and there, but this module will go into it in quite a bit more depth. So here's what we're going to be looking at. One is how to access characters. And that means given a string, we can basically treat that string like a list of characters and go and access each individual one. We'll look at concatenation, which, as we remember, just simply, we've got a string, got another string, and we're going to add them together, so to speak. We're going to join them. So we'll talk about concatenation, and there's two ways to do that. One is to use the concatenation operator like that, and then the other is just using the join method. And I should have mentioned for accessing, we can treat strings as though they were lists, so we can iterate through them using an index. Let's see, we'll talk about repetition. And that's how we can basically take a string and repeat it a certain number of times, however many we want, and capture that entire new entity as a concatenated repetition string. So we'll look at that. This is the big one, though, splitting. We'll take a look at how to take a string and split it into its tokens using certain delimiters. And a delimiter most commonly is going to be the space character. So we can give it a sentence in a string, and splitting is going to go through that string and parse out the tokens, or in other words, isolate the words, assuming that our delimiter character is a space character. So we'll look at that. We'll also look at modifying. We can look at modifying elements of the list. How would we go about that? Lists in general, strings in general are immutable, and that means that we can't change individual characters, but we can do kind of a reassignment. We can concatenate and then assign that return value. So we'll go over in pretty good detail about how to do all that modifying. We'll also look at search and replace. And there are string functions that help us do all of that. A big part of this module is going to be character testing. And that's going to look like we're given a string and we iterate through it. So every time we go through that loop, we've got a certain character in our hand. And character testing would look like, well, what is this character? Is it an alphanumeric character? Is it a digit? Is it an uppercase? Is it a lowercase, etc.? We can do testing for all of that and even compile statistics if we want. And then the last thing we'll look at is reading CSV files. Given a CSV file, that's basically an Excel spreadsheet, but the data elements are separated in file by a comma most commonly. How can we read these into Python lists and modify them as necessary to process that record? So all of this is in store for today. Let's start with accessing our elements. Okay, let's take a look at how we can iterate through a string. So let's say that this is a string here. And the just marvelously intriguing phrase, I really like vanilla. So if this is a string variable, okay, let's give it a name here. I'll just say str. We can assign it to a string variable there. What we can do to iterate through that string, and by iterate, I mean we're going to go character by character by character just in a loop. We can just use a regular for loop for that. That looks like this. The for loop is just for ch in the string name. And ch is a programmer defined entity. You can call that anything you want. It's common if we're going to iterate through characters just to use ch or chr. or char, I should say. Don't use chr because that's a reserved keyword in Python. Then inside this loop here, anywhere right in here, we've got ch in our hand, and we can do whatever we want with that. If we wanted to print it, we can do that. If we wanted to do some other modification, we can go ahead and do that. Let's see. We can access individual elements, though. So a string is really nothing more than a list of characters. I mean, if we have the character I, and then the character space, and then the character R, and then the character E, and if all of these are listed in a Python list, together collectively, they form the string that we defined. The beauty of this is that we can treat it like a list. So that means that we can use an index to retrieve specific characters. So what would this look like? Well, if that string variable is called str, then str0 will access the first letter in the string. str1 will access the second element in the string, and then we can just iterate all the way through that. So there's, being that we now can iterate using an index, then we can use either a while loop or a for loop to just simply go through that. A for loop would look like this, nice and easy. For I in range, and then let's give it, the length of the string. Let's just call it 6 for now. And we can then inside this do whatever we want as long as we reference str sub I. So whatever we want to do with that, that's our reference, str sub I. We can print it. We could send it to a function. We could manipulate it. All of those things are at play. All right, so let's take a look now at some of our code to support this. Okay, we're back. Here's a notebook showing all of the various string operations. First, here is what we talked about, iterating through a string using a standard for loop. And here is that structure in the for loop header for ch. That could be for char, whatever we want. I'll make it for Charmander. And then we run it and we get the full string listed there. So what this is doing is it's going character by character through that string. I'm going to change this back because ch is more of a convention to use. Now, I mentioned before that strings are immutable. Here we're going to access a couple of characters within the string. We're going to access the second and third characters using the list index 1 and 2. But then I'm going to try and change a certain character, and we're going to draw an error. And this demonstrates that these lists are in fact immutable. You can't change them. We can reassign them, and we sure take advantage of that feature in our coding, but we can't outright just reassign a letter. So here's an example. Here we're printing out name sub 1, which will be the second character, or O right there, O. Here we print name sub 2, but then here we attempt to change name sub 6, or the 7th character. We try and change that to a capital Z. And of course we get an error message with that. So I'm going to comment this out now, and our code will now run without an error. Now, I mentioned before, there are a couple of ways to iterate through the loop if we're using indexing. One is with a while loop, and the other is with a for loop. Now, there's a string function called len, L-E-N. It's the same that we use with lists. Well, if we use it on a string, it's going to return the length of the string. So a very common way is to structure your loop so that we use the length of the string in the header. Here's a while loop header that does exactly that. It's saying while I is less than the length of the string. And then over here is a for loop that also uses length of string for our for I in range header. And you'll see that if we run these, all of them just output the entire string as expected. And that's the behavior we were hoping for here. Okay, let's take a look now at string concatenation. And that is simply appending one string onto another. We can always use the concatenation operator, which is the plus sign. And when used with strings, it's not, of course, the addition operator any longer. It's the concatenation operator. And we're just simply going to take name one or string one and use the plus sign and use name two or string two, whatever we would like. And it concatenates those. It returns both of them together. And you'll have to do something with the return value like we always do. It's going to be common to just assign that to some type of a variable that's going to store what got returned. Or we could print them or use that in some other function. But most common is to output it right away or to assign it to another variable. So this will work quite easily. The concatenation operator also works with specific characters. So if we wanted to say name one, and then maybe we add the comma character and a space here, then we can do that between both of those. And this will then put the small string, comma, space between name one and name two. So that's using the concatenation operator. There is a join method you can use also. And in some circumstances, you'll be required to see this, see the latest video for more information on that. But usually the concatenator is going to be just fine. Now, the way we do with the dot join method here is that we will either assign or print whatever we want. We will just simply use a kind of an odd looking convention, but it sort of makes sense. We're going to print, in this case, let's print. And we're going to print the empty string and then joined with, and then there we put the strings that we want to have named or have joined. So like string one and string two. So both of those work. One is a little easier. One might be required depending on the application. And you'll see some code here in just a second. Let's go back to Jupyter Notebook now and look at some code. Okay, we're back in our Jupyter Notebook. We'll look at concatenation first here using the concatenator operator. And here I've got a name one declared, a name two declared. And here I'm going to go ahead and reassign name one, whatever name one was, and then we're going to concatenate this colon, space, combination, and then name two to it. So we should end up with this, and then a colon and a space, and then this line here. So we run that, and you see that that's exactly what we get here. The concatenation operator also works as a combined operator. So you can use plus equal just fine. Now here's an example that uses the join function. Now join is going to take one argument, and it's basically a list of things that we join together. So here in this case, I'm going to join the name one string. Then I'm going to join the combination of colon space, and then we'll join the second name. And we run this and we get the full thing output here. Now it's interesting, what we do is we take this empty string here and we use .join for it, and we're going to join everything in this list to this empty string. That's just how that works. So pretty straightforward for concatenating. So just remember the tricks. The plus sign works. The combined assignment operator works. So plus equals works. And then .join works also just as well. Okay, let's take a look now at string slicing in Python. And string slicing is identical to list slicing that we looked at a couple of weeks ago. Here's some of the rules if we remember them from list slicing, and they apply to string slicing as well. First, negative numbers will just count from the end, and positive numbers will count from the beginning. Now, there are 3 arguments in slicing. The first 2 are, well, actually all of them are kind of optional. If you omit the first one, then the assumption is that we start at the beginning. If we omit the second one, that means we're going to continue up to the end. And then of course, the third one is truly optional, and that's just going to be a skip value. So let's take a look here. We've got this string right here, Beyonce, for a want of a better string. It's kind of an awesome string. She's good. Let's take a look at these list slices and what they might return. So the first one is just :5. So it's missing that first argument. And that means then we assume that we're starting from the beginning. So this is going to return character numbers 0 at the beginning, and it's going to go all the way up through, but not include 5. So it'll pick characters 1, 2, 3, and 4. And just like we've seen before, very common behavior, the n value is never included in the solution set or in the return set. So we stop at 5 without including it. So here we would get these letters, B-E-Y-O-N, the first 5. This next one starts at the second index number, which is actually the third character. So this is going to start at 2 and go until 5, but not include 5. So this will return 2, 3, and 4. So those characters are going to be just Y-O-N for, since B is character 0 and E is character 1, it's going to start at Y. All right, now this example here, we've got that second argument omitted. So the assumption is let's continue to the end. So this will take, return a string starting at the second character, I should say the index character, which is really the third character, and go all the way to the end. So the second character, as we know, index character 2, I should say, is going to be 2, 3, 4, and we go 5 and 6. So this is going to return Y-O-N-C-E. All right, now this next one, oh, there's my dog. Everyone see her? There's Pepper. Hey, Pepper, wave to everybody. Here we've got some negative numbers, so that means we're going to count from the end. This is saying start 3 from the end. So let's just kind of look at this here. I'll change the pencil color here to show. This is the first from the end, this is the second from the end, and this is the third. So we're going to start at the N here and go until 1 from the end, which is the E, but not including that. So this is going to return an N and a C for us. Now, if we omit that second argument, it's going to go to the end, and that'll give us then NCE. And if we omit the first argument, but have a negative number for the second, this means start at the beginning and end 3 characters from the end. So this is going to give us a BEYO. So hopefully this is just more of a refresher. Let's go and take a look at some code now that'll show and demonstrate these string slices a little more. All right, here's our string again. We've got the John Jacob Jingleheimer Schmidt name assigned, and here's just a bunch of different slices. First is 0 to 10, and yes, we could optional make that first argument optional since it's a 0, and 0 is going to be the default. And this will print the first 10 characters, characters at indexes 0 through 9. So we see that this works here. I'm going to go ahead and change the first argument just a little bit, just to show that the behavior is exactly the same, whether you put a 0 in there or not. This next line is going to start at element 5, which is going to be this second capital J, and it's going to go then to character 25, which is going to be right to about here. So that prints that. This one here is going to go from character 5 to the end that we saw. This will go from the beginning up through, but not including character 12. This one starts 5 from the end and goes to the end. This one starts 5 from the end and goes and stops at 3 from the end. And then this one starts at the beginning and we stop at 12 from the end. So when we run this, you can see that we get all those varied results there, showing just how the list slicing impacts a string. Okay, let's take a look at the repetition operator with strings, and that is the asterisk. In math operations, it's of course the multiplication operator, but with string operations, it's rebranded and it becomes the repetition operator. And it's just simply going to take a certain string and repeat that exact string a certain number of times. That's all configurable. I'll show a code or some sample code here in a second that puts this in a loop, and we can then print a variable number of characters in a string. So first, this very first one here, the string nm, if we do that, repeat it twice, that's going to give us this string here. nm and m, of course. If we had the string z, uppercase Z, it still is a string, even though it's just one character. It still counts as a string. This is going to return z, z, z like that 3 times. And of course, we can then take whatever we want for the return value, store it. There's a variable result. It's just going to store the return value there. Now, interestingly, we can also put that in a loop. Here's a for loop right here. That's saying, okay, for C in range, and that's going to give us a for loop. C is going to equal 1 the first time through and 2 the last time through. And then our instruction here is we're just going to print Z C number of times. So the first time through the loop, we will get a Z. The second time through the loop, we'll get that coveted double Z. So let's take a look at some code now that supports that. Here are 2 of them. 2 loops, and these are simply going to sort of print a sideways pyramid. This is saying, all right, so count is going to go from 1 to 9 inclusive, and then just print out that many Z's. And then this second for loop is going to do sort of the descending portion of that sideways pyramid, and we'll start counting, of course, at 8, and we'll stop at 1 inclusive or 0 exclusive. And we'll go with a step value of -1, and we'll do the same thing. So we get this cool, let's run it first of all, and we get this cool little sideways pyramid. So that's our repetition operator. Next up is string modification in Python. We can take an entire string and apply various string methods to it, and it'll convert or manipulate or modify the entire string. Here's a couple. If this is our string here, hello, students, and welcome, the .lower method is kind of cool. It's going to just convert all of these to lowercase. Now, they are already lowercase, except for that first word, which is capitalized. So this is going to return hello, and then etc. Similarly, .upper is going to convert every single character in the string to an uppercase. And if it happens to be a space character, or it happens to be a punctuation character or a digit, well, then it's just ignored. There's no modification that happens with that. So we would start here and we'd get hello, all capital, and then the rest of that, that string there. Now there's a .title method that applies to strings also, and .title will modify the string so it's in what they call title format. And title format is where every word is capitalized. So this would give us a capital hello, and then a capital students, and then a capital and, etc. Okay. Now, I mentioned before that some string operations only work using the .join method, and reversing a string is one of those. Here's the syntax for it. We're going to actually call a, this is not a string method, but it's actual Python function called reversed with a D, kind of past tense reversed. It takes the string argument, and what we do, that gets returned, and we join that to the empty string. And this works because, there's a technical reason behind it. What's being returned is actually an iterator, and that's a little different. So that's why we have to use join for that. But this will result in that entire string being, see if I can do this, reversed, starting with the last character first and then going all the way through. So here's some sample code that supports that. Let's shift over to the Jupyter Notebook. And here's our string. Opportunity is not a lengthy visitor. We can apply dot lower to it, and then dot upper to it, and then dot title to it, and then reversed, the function reversed. We print out all of those, and then you can see the results here, how the strings have been properly manipulated. Here we do see all caps. Here we do see the title format where every word is capitalized. And then here is the original string completely backward. Okay, let's talk about searching and replacing with our Python strings. We'll use two separate string methods for this, dot replace and dot find. Dot find is interesting. It's going to return a number. It returns the index number of the first instance where it was found, or if it's not found, then it'll return a -1. So dot find is going to take an argument that's going to serve as our search term. And again, it returns where in the string, starting at the beginning index, that the search term was found. And again, it's going to replace or return a -1 if it's not found. So what we do then is simply, we can ask, well, if let's assign it to a variable. So let's say that position equals string.find, and let's give it some kind of a search term, ABC. So position then can be evaluated. We know that it's either going to be a positive integer where it was found, or a 0, I should say, if it was found at the beginning, or a -1. So we can basically then say, well, if pos is greater than or equal to 0, well, then it was found. Else it was not found. And then not only that, we can also report, well, where within the string was it found, just by also outputting the variable pos, because that's just going to be an integer. So here's some code now that we can take a look at with these. Here is our string. Opportunity is not a lengthy visitor. If you're watching this video and you've made it up to this point, let me give you a little Easter egg. If you know what that what that statement there is from, which musical, then email me and I'll give you 1 point of extra credit. It's in a musical and it's an awesome musical. And which one is it? All right. Now here our search term, I'm going to create an actual variable for it, and I'll call it just PRT. That's the string that we'll search for here. Here's the dot find method. And like we just demonstrated on the whiteboard, I'm going to assign the return value here to this integer variable called position. Now the dot find method takes one argument, the search term. And here, of course, we can test position if it was found or not. We're guaranteed if it's 0 or greater, we're guaranteed that it was found because we're given a position. If it is less than 0, then we know that it's not found. So here we did see the output that the search term port was found at position 2, and that does make sense because port starts right there at the third character, which is index 2. Now replace is similar, except the dot replace method is going to take 2 arguments, what the search term is and what the replace term is. So it's going to, in this case, still operate on string 1 here. Opportunity is not a lengthy visitor. We're going to search for the string NOG. And if that exists, we're going to replace that entire string NOG with this string always. So let's check out what the result is there. And it looks like we got no change in the string. And that sort of makes sense because the search term is not found in the string. So it just was unaltered. Let's change this code here to not, so that the search term now is not. And run it again. We do know that not is in that string. It's a substring. So we run it, and now we get the replacement happening. Instead of opportunity is not a lengthy visitor, we get opportunity is always a lengthy visitor. So that shows how this replace operation was successful because the search term was found. Okay, let's look into some character testing. What is this? Well, we can test a certain character and get some information from it. For example, let's say we're iterating through a string, right? And every time through that loop, we have an actual character in our hand that we can now look at and say, what is this? We're able to tell through character testing if that character is an uppercase letter, a lowercase letter. We can tell if it's a digit 0 through 9. We can tell if it's an alphanumeric character, which means all of the letters and all of the numbers together, that forms the alphanumeric set, and we can test if it's alphanumeric. We can also test to see, is it a white space character? And a white space character is going to be the space character and the tab character, and even the new line character is considered a space character. We can check to see if it is, let's see, I think, yeah, those are the main ones. The ones we're going to start looking at here are just these that I've got listed on the screen here. Is upper or is lower. So let's say, for example, here we've got this for loop that's just going to blast through a string, and every time through it's going to assign the variable ch to whatever character we're currently working on. Well, we can use the dot is upper or dot is lower methods to ascertain if it's an upper or lowercase character. Now, all of these methods are Boolean, so they will return a true or false, but then we can use that in a relational expression or a logical expression and get our character testing done. So here inside this loop, we could just simply say, well, if the character dot is upper, and remember that that returns a true, so we can just simply use the return value as either true or false. So this is saying if it is an uppercase letter, well, then here in our code, we would do whatever we wanted to do. Maybe we increment a counter. Maybe we output it. Maybe we, I don't know, do something else. Then our else clause will then kick in if it's not an uppercase character, and we can then take care of that. So let's take a look at some code next. Okay, let's check this code out now. Here's some character testing on this string. The string is the kind of September. Here, our for loop is just going to step through that character by character. And this is the code that I just mentioned on the whiteboard. Now, isUpper is a Boolean method. It returns a Boolean, and we can test against that simply with the if statement. So if the character is an uppercase, then we output that result. So when we run this, we see that we get all of these results here. Capital T is uppercase, everything else is lowercase. Interestingly, it does consider the space character as a lowercase, and then there's one other S in there. Now, what we could do is we could try adding a counter to count the number of uppercase and the number of lowercase. Why don't we do that? So let's just create a couple of counter variables here. How about called uppers and lowers? And then let's initialize both of those to 0. This statement does work. It'll initialize both of those integer variables to 0. The way it does that is it first looks at everything to the right of the first equal sign and tries to resolve that. So it does that by setting 0 to lowers, and that then is going to, if we just then call lowers, it's going to be a 0, and that gets assigned to uppers. So it's kind of a daisy chain assignment all the way down. Then inside here, we will just say that if it is an uppercase, let's go ahead and increment the upper count. So uppers is going to be plus equals 1. And then in the else clause, lowers, if I spell it right, is going to then get incremented there. So here we can simply print out the number of uppers. Here's just sort of guerrilla coding. I'm just going to print out the results real quick. And I am going to comment out the print statement so we get just the results here. And there we get the results. There's 2 uppercase and 19 lowercase. So pretty straightforward. Here is some other string testing examples. Here's string 1 with the string ASDF. Here's string 2 with some numbers. And then here's string 3 with alphanumeric characters, all mixed in together. So now what this code's going to do here is first analyze string 1 and ask, okay, is it an alphanumeric, is it a digit, or is it an alphabetic string? Now what this is doing is we can character test is digit, is alnum, etc., but we can also test the entire string. So that's the point of this little segment of code, is that we're going to apply these methods not just to a character, but to an entire string, and we can do that. Here it's saying then that for string 1, it is an alphanumeric. That's correct. It's not a digit, and that's correct too, because there's only letters in it. And it is true that it's an alphanumeric. I'm sorry, an alphabetic string. It only has alphabetic characters. All right, and then 4, 5, and 6 are the results of applying these same tests to string 2, the 5, 6, 5, 6. And we see that, yep, it is an alphanumeric because it's got some numerics. It is a digit, but it's not an alpha. And then we apply the same thing to string 3, and we get those results there. All right, let's talk about splitting strings up into tokens, or another term for this would be if we got a sentence and we wanted to break it up into words. We can do that with the dot split method. Again, it's going to take a string and parse the string into tokens based on a certain delimiter. Now, the default delimiter for the dot split method is the space character. And that's convenient because most of the things that we'll want to kind of tokenize here is, might be a string with some words in it. The dot split method also takes an argument that's optional, and it would be another character that you might want to use as a delimiter. For example, maybe the delimiter would be a comma. We've got a comma separated string, and we can maybe use like the vertical bar or an asterisk, whatever the delimiter is. We can just supply it as an argument to dot split, and it'll use that as the delimiter. Again, the default though is the space character. Interestingly, dot split returns a list. This is one of the most important things to remember. It returns a list of those tokenized elements. So if we apply dot split to a string variable that represents a sentence, then we will get back all of the words of the sentence with the spaces removed. The delimiters are not included in the solution space here. So let's take a look at code that supports this. Okay, here is a notebook cell about using dot split with the default delimiter, which is again the space character. All right, now here is a string. It's this string here. Try to remember the kind of September. Hey, and if you're watching, let me throw out another little Easter egg. This phrase is from another musical. So email me the name of the musical and I'll give you 1 extra credit point. Now, the dot split method here works on the string. So we append it to the string name itself. And we've got to remember that dot split returns a list. And if we don't then assign that return value to a variable, well, then it's just simply lost. We've got to assign it to a variable. So here I'm going to assign it to the variable word list, and now word list is going to end up being a list of the words in the sentence. So first I will print out that, and it's going to print out then this list of strings. Then what I'll do here is just use a for loop, and we will go through this list element by element, which is word by word, and just simply output it. And there's that output there. Now, here's some code that uses a different delimiter. This time, the string contains the same words, but we're using this vertical bar as the delimiter. See that? Let me try and select it. There we go. So the dot split method can, again, take a character as an argument, and here we'll give it that vertical bar, and it'll split all of these tokens just like it did before, but with a different delimiter. So here you see that we get the exact same results that we did before, exactly the same. Okay, let's next talk about how to process comma-separated files in Python. Now, our code so far has been just using local data. We looked at how we can parse tokens using various delimiters. If we used a comma delimiter, then we could see that if we had a line of data separated by commas, well, we can now just tokenize those quite easily with dot split. And it will return a list of the tokens that it successfully extracted using the delimiter that was specified. Well, this lets us suddenly be able to read a comma separated file like that. I mean, we already know how to open a file. We know how to use the read lines operation to read every single line and have that stored in a list of strings. Every line is going to be an element in that list. And then we've seen that we can just simply go through that list of strings line by line and do whatever we need to do. So here is the code then for our comma separated files. First in line 1 here, we simply open the file, and let's remember that we will need a file name here. And then the mode is going to be the read-only mode, which if we remember from our file operations, it'll be the R character as an argument there. Then line 2 here is the operation that reads the entire file all at once, and it creates a list called lines, and every element in that list is one string of the data. Now, if we were reading in numeric data, all of that numeric data is stored as a string, not as a number. So we're going to have to remember to take the extra step to convert it to an integer or to a float, whatever we need to, later as we process this comma separated file. So remember that everything is a string until we tell it otherwise. Now line 3 here, that for loop header is just now going to go for line in lines. Line is just a user-defined entity there. And our first thing that we'll do is we'll take that line, that's the first element in the list lines, and let's split it up and tokenize it. And at this point then, when that's done, then at our disposal, we have elements available for processing or manipulation that exist in tokens sub 0, because remember, tokens is a list. The dot split statement always returns a list. So token sub 0 will have some data in it, token sub 1, clear up to whatever token the length of tokens is. And we can access that also just with the length of the tokens list. It'll return how many words then are in that sentence. So with those kind of core things, we can do a lot of cool stuff. Let's take a look at some code that is going to process a comma separated file that represents dogs and their scores on dog training tests. So similar to the mention that I did in the previous lab, here are 4 dogs, Fluffy, Fido, Rover, Princess, and their test scores. There's 3 tests. So remembering the structure of this, there are basically 4 fields per record in this database, the first being the name, and then test 1, test 2, test 3. So let's remember that structure. Now, our first statement here simply opens up that file. I called it dog.csv. Our second statement, just like we saw on the whiteboard, is going to read the file and store every single line as its own string in the list lines. Now here, I'm going to create some empty containers for processing. The goal here is we want to store all of the test 1 scores in one list, all of the names in another list, all of the test 2 scores in another list, and all of the test 3 scores. That way we'll be able to sort of aggregate our data. We can say, well, what was the average on test 2 for all dogs? We can also, I'm going to store the sum of every dog's individual score, and we could get an average for each dog. So what was Fido's average for all 3 tests that they did? So we'll be able to answer these questions here in no time at all. So here's the code For line and lines is going to process every one of those string lines in the list lines. All right, here we split it up using the comma delimiter. Now, the first thing I'm going to do, since we know that token sub 0 represents the name of the dog, I'm going to go ahead and append that into the names list. We saw up here that names was initialized to be just an empty list. So here I'm going to append to it. Here, we've got to remember that when we read this file and we read any particular line in that file, we have to remember that the new line character is also read and stored. So in this case, it's going to impact the fourth token. Again, we've got name, test 1, test 2, test 3. Well, this fourth token is not only going to have the 1 and the 0 stored, but it's going to have the new line character also. So we take care of that by simply using the rstrip method. We give it what character we want stripped, and we strip that from the token. So now it's going to be a number that we can then operate on. Now, remember the mention from before that we're still dealing with strings. So even though, yep, we stripped the new line character off of that third test token, it's still a string. We have to convert them explicitly by casting them as integers. So this is what that code's going to do. It's going to convert the second, third, and fourth tokens from strings to integers. So for I in range here is going to look at token elements number 1, 2, and 3. And that makes sense to us because token 0 is the name. Now here's some code. All I'm going to do is append those test scores to the appropriate container. We're throwing all of the test 1 scores into the test 1 container 2 and 3. Okay. Then finally, I want to get the sum of these dogs and append that to the dog sum. So I'm just going to add the 3 tests. And the sum then is going to be appended to the dog sum. And let's see here. I don't need this. So let me take that out real quick. Then you can see here, well, when we print and run this, we've got 3 test averages that we've calculated. And for every dog, we've calculated their own average among their 3 test scores. So how did we do that? Okay, easy. Just here's some print statements. We do know that test 1 contains a list of all of the test 1 scores. And we can call the sum function to that list, and it'll return the sum of that list. So we didn't have to manually go through. Remember, we can use these methods that we studied 2 weeks ago and then last week for various list operations. So it's really convenient that we've made lists because we can then sum the whole list just in one statement. So there's all of that code as well. All right, if you survived this long, congratulations. I hope that this video helps, and I hope working through some sample problems helps also. I would like to say that if you want a copy of this sample code, then just email me and I'll send it to you. Another little Easter egg. All right, good luck this week, class. We'll talk to you soon.